Hi, this is King of Review. In a basketball game, Noah scored 34 points. He had 15 successful 2-point and 3-point shots in total. He was the highest scoring player of the game. How many 3-point shots did Noah successfully make in this game? So what we want to do is make a couple of equations that represent this situation. But before we do that, we want to define what our variables are. So let's let x equal the number of 2-point shots. And let's let y equal the number of 3-point shots. So using these variables, let's set up an equation. Well, we see here that he had a total number of 15 successful shots. So the 15 shots are made up of both 2-point and 3-point shots. So if the total number of shots he made was 15, that's going to be equal to the number of 2-point shots that he made plus the number of 3-point shots that he made. So x, that represents the number of 2-point shots, plus the number of 3-point shots. That's y. So here's our very first equation. And this is x plus y equals 15. Now let's think about another equation. We see here that he scored a total of 34 points. So how was this score made? Well, it consisted of both the 2-point shots and the 3-point shots. So the number of 2-point shots that he made, well, that's x, and each one is worth 2 points. So we can say 2x represents the points that he made consisting of the 2-point shots. And then if we look at the 3-point shots, they're worth 3 points each, and if he made a total number of y of them, then 3 times y represents the total points made from 3-point shots, so plus 3y. So 2x plus 3y equals 34. That's our second equation. So here we have a system of equations. We want to solve for x and y. So if you notice, these equations are in the form ax plus by equals e and cx plus dy equals f. They're in the same format. So we can use a method called Cramer's rule to solve the system. That is, solve for x and y. Cramer's rule states that you can use determinants to solve a system of linear equations. And this rule says that x can be found by taking the determinant of the x matrix and dividing it by the determinant of the coefficient matrix. And likewise, y can be found by taking the determinant of the y matrix and dividing it by the determinant of the coefficient matrix. So we need to set up our 3 matrices. Let's start with our coefficient matrix. Now the entries in this matrix, those are going to be the coefficients of the x and y terms. So A, B, C, D. The x matrix, we'll start with E and F. And you can see that E and F are these constants that are in the 2 linear equations, and the other entries are B and D. And then the y matrix, this is A, C, E, and F. So this is how we set up our matrices. So let's go ahead and put in our specific values. Well, look at the coefficients. We have 1, 1, 2, and 3. So 1, 1, 2, and 3. And now for the x matrix, E and F, well, those are the constants, so 15 and 34, and then B and D. And then for the y matrix, we have A and C, and then E and F. So now we have our three matrices. But if you notice here, when we solve for x and y, we actually need the determinants of these matrices. A determinant is a real number associated with a square matrix. So let's say we have a matrix with entries A, B, C, D. The determinant can be found by taking the product of the main diagonal, A, D, and subtracting the product of the other diagonal, C, B. So AD minus CB, this is how we find a determinant. Let's find the determinant on our coefficient matrix. Well, we take the product of the main diagonal, 1 times 3, minus the product of the entries in the other diagonal, 2 times 1. So 3 minus 2, that gives us 1. Now let's find the determinant of our x matrix. Well, we have 15 times 3 minus 34 times 1. And when you work this out, this is equal to 11. And the determinant of the y matrix, well, we have 1 times 34 minus 2 times 15. And when we work this out, this is equal to 4. So solving for x, we have the determinant of the x matrix. We solved for that, that's 11. Divided by the determinant of the coefficient matrix, that's a 1. So this is equal to 11. X equals 11. Solving for y, we take the determinant of the y matrix, that's a 4, and divide it by the determinant of the coefficient matrix, that's 1. So we get 4. Y is equal to 4. But what do these numbers mean? Well, let's return to up here where we identified what we were going to let each of the variables equal. So x, well, that's the number of 2-point shots. So there were 11 2-point shots. And y, well, that's the number of 3-point shots. So there were 4 3-point shots. Now the problem says how many 3-point shots did he make? Well, we see here we solved for y, and y was 4. So he made 4 3-point shots. The final answer is 4. Thanks for watching.